First, let me introduce BSB. BSB is a leading provider offering sales of BTUs and heating equipment. We're distributors of Macy's, Okofen, which used to be Okofens, Hertz, and Binder boilers. We are also distributor of Marbury forced air unit with applied to different applications such as greenhouses, poultry farms, commercial industrial building, and warehouses. Our two shareholders are two well-known businessmen from New Brunswick, Jean-Claude Savoie, Groupe Savoie, owner of Groupe Savoie, and Malcolm Fisher, owner of Compact Appliances and Northeast Distributors in US. Here's a picture of woodplant pellet in Groupe Savoie with a production capacity of 90,000 metric tons a year. This is our pellet truck, first of its kind in Canada, because we all say it's first of its kind because it's have 4 rising scales. As you can see on the bottom of the truck here, you got 4 rising scales, which allow measurement of the exact weight of pellets delivered to the customer. Every year, these scales are calibrated by Measurement Canada to make sure that they are accurate and certified for public delivery. Every customer will receive a print slip which identifies the exact pellet tonnage delivery in each location. This truck is also equipped with a closed loop dust recovery, a vacuum system for inside seal bins. You can see the holding tank right here on the right front of the truck. As shown in this picture, from the back of the delivery truck, we have 100 feet of blue hoses to push inside the silos. And we have 100 feet of green hoses to recuperate the dust created in the tank when delivering pellets. This is a typical installation at one of our customers, which have a 3.5 ton silo, and it's 7.6 high by 6.6 inches wide. Typical small installation, which shows the pellet boiler on the left in the green, including a 120 pounds pellet holding tank on the right, which is fed by 2 vacuum systems from a 9-ton pellet container. The storage container normally will be installed in an outside wall where you have access to our truck for bulk delivery. The first story will be the church in Saint-Quentin. That's where we started on November 2013. Their original heating system was 2 oil boilers with a capacity of 96 kilowatt each for a total of 192 kilowatt. We installed 2 56 Okofen boilers with 2 119-gallon buffer tank, including a 9-ton pellet storage inside the basement church and a new liner in the existing brick chimney. At the beginning, we calculate the estimated saving will be around $24,000 per year, minus the consumption of oil at the peak demand of about $7,000 in winter. Therefore, a total savings of about $17,000 with an anticipated payback of 5.5 years. Their heating cost in 2011-2012 was $30,810 at the cost of $1.10 a liter, while in 2012-13 their cost was $26,841 at 98 cents a liter. In 2013-14, the heating cost with pellets dropped to 10,656. The saving compares to previous years was 20,159, which is represent about 65% saving, and 2012-13, 16,185 for a saving of about 60%. And the final payback was 4.5 years. In 2018, the federal carbon tax in New Brunswick was established at $20 a ton. From 2018, the biomass installation that the church have saved an additional $1,750 a year. We estimate 87.5 tons per year times 3. That makes 5,250. If you take the carbon tax into consideration, the return on their investment will be even quicker. Here's a couple of photos of installation at the church. The 2 Okofen on the left-hand side and the 2 buffer tank on the right-hand side. On the left, far left, is the old boilers. On the middle is the vacuum system. And on the right is the 9-ton storage pellet. St. Town Hall, second story. We have a very similar than the church. Their original heating was 2 old boilers with a capacity of 96 kilowatt, each for a total of 192. The oil consumption in 2013 was 22,000 liters at $1.13 for a total cost of $25,000. On March 24, we installed 2 Okofen boiler, 56 kilowatt, including a 120-gallon buffer tank and a 9-ton pellet container. Winter 24-15, their heating cost with pellet was $10,000 for a saving of $15,000 compared to the previous year, 2012-13, which ended up with a return on their investment for 6.5 years. In 2015, they add up their maintenance building to the existing pellet heating system to replace the old furnace, which therefore add another 4,250 square feet to their heating load. Even with that additional heating demand, they are still saving $8,000 a year. Plus, since 2018, the replacement of all consumption reduced their emission of CO2 by 61.3 tons a year for an additional saving of $1,226. Here are some pictures of their installation. We got the 2 Okofen, and right, the feeding pellet hose connected to the boiler storage tank. On your left is the back of the boiler showing connection to the chimneys and the insulated piping distribution hot water system. To the right, you have 2 insulated buffer tank. A typical bidder commercial industrial biomass boiler. Starting from your left, we have the heat exchanger door on top, which will give you access to the tube for cleaning where the ash residues fall on the right-hand side, dropping into the ash hogger at the bottom. Second on the left, you have the water jacket boiler with combustion chamber refractory and heat shield to protect the hot flames going directly on the exchanger tubes. Bottom left, we have the wood pellet feeding hogger, including the electric igniter and anti-back burner door. At the bottom, from the left to the right, we have the moving grate which take gradually the pellet burning cycle to ash. Then at the end of the moving floor, the falling ash goes into the transport system, which move automatically the surplus of ash in the ash bin on the side of the boiler. In 2011, the province of New Brunswick decided to move ahead with heating the Grand Falls Hospital with a wood pellet boiler by using an RFP, by issuing an RFP. The purpose of the RFP was to invite private sector proposals to submit a turnkey solution to utilize local renewable energy source to reduce dependency on fossil fuel and develop new markets for the wood pellet manufacturing plant in New Brunswick. The proposed concept was to provide the capital cost to own a complete standalone wood pellet boiler room outside the hospital, which is to include the fuel supply, maintenance, and full operation of the plant for a period of 10 years. BSB was awarded the energy contract agreement in 2012. In 2013, we started to supply heat to the hospital, and in 2014, we added to heat their domestic water. The supply heat energy load is monitored with a BTU meter inside the hospital and invoiced monthly as per contractual agreement. This picture shows our truck, our 12-ton delivery truck, into the 55-ton pellet silo, and also a front picture of our boiler room. Here's a view of our 840 kilowatt binder boiler installation showing the feeding auger, the boiler, the ash bins, and the dust collectors, cyclone on the far right, and the ash bin. It's important to notice that calculating the proper boiler and the buffer tank size on any biomass heating system is very important. This combination will play a major outcome on the efficiency results at the end. As an example, the boiler here is oversized, but we are efficient because of the huge size of the buffer tank, and also that this boiler full capacity can modulate down to 20%, which then make longer heating cycle and help in the summertime to provide heat to the domestic water. Here you see the back of the picture is a 23,000 liter buffer tank with all the distribution system, including the circulating pumps, pushing the hot water inside the hospital by underground piping. Just to demonstrate the flame, the combustion chamber, which can reach over 800 degrees Celsius. The first winter, 2014-15, we calculated savings of 168,000 liters of oil for an equal consumption of 425 tons of pellets, avoiding the emission of 512 tons of CO2 and additional saving of $10,240 at $20, calculating the carbon tax at $20 a ton. Winter 2015-16, we calculate a saving of 246,500 liters of oil by adding the capacity of heating their domestic water. We burned 480 tons of pellet that year, avoiding 784 tons of CO2 emission, representing a additional saving of $15,680. Here are some pictures of the King Street Elementary School in Miramichi. The new school built in 2018 has an in-floor hot water heating system heated with a 300 kilowatt wood pellet binder boiler, with 2 backup propane boiler. On top left, you see the picture of the school, the 2 propane boiler on the left, bottom left, and the 300 kilowatt Binder boiler on the right. In 2018, they used propane from September 2018 to the end of February 2019 until the pellet boiler was in operation. So you can see the benefit once the pellet boiler was working as expected versus the propane usage in 2018. But the most difference is in 2019 and 2020, when the full operation of the pellet boiler was in full operation, and you see the difference of propane consumption versus pellet. In 2018, the Community College and University de Moncton in Sheboygan campus project needed to replace 3 all-steam boiler with a large enough heating system that will meet the requirement for an additional expansion of 36,000 square feet existing to their footprint. The first wood pellet steam system in North America, which heat 160 square feet of combined building, consume about 500 metric tons of pellets per year, with an estimated 85% reduction of CO2 emission annually. Picture on the left is the back of the cyclone collecting fly ash. Middle is the front of the combustion chamber with the cyclone, and on the right is the steam drum. In 2017-18, their all heating consumption was $158,000. In 2018-19, they added 36,000 square feet to the building. All heating costs was $97,000 plus wood pellet cost was $95,000. The difference here is that the biomass final installation was only complete in mid-December of 2018 and really bring in production about in January 2019. But the real difference is in 2019-20, their first year with the new expansion and the first year with the full pellet wood system working. The heat cost was $20,000 for oiled plus $109,000 for pellet for a total cost of $130,000. Therefore, their first year of full operation with pellet, they're saving compared to 2018-19, automatically $62,000. Let's jump to some more example of. On top is a picture of Greenwood house built in 1836, which was before the President House of Mount Allison in Sackville, and now used as a bakery cafe. In 2014, we installed a 56 Okafen, you can see on the far left bottom, as the primary heating system, and also heat their domestic hot water by replacing natural gas boiler. Their heat cost was reduced by 60%, and their payback was 6 years. CDC hydraulic, we installed in 2014, a 56 Okafen boiler with 220-gallon buffer tank. The installation was to replace all boiler, and their saving was estimated at 65% at a payback of 5.5 years. In 2018, we supplied this 1 megawatt wood chip boiler to Les Serres Galician in Abitibi-Témiscamingue area, which have a greenhouse footprint of about 75,000 square feet. That was to replace their oil boiler.
Yeah, if we want to move on, then we have a couple of questions here. So the paybacks that you showed are obviously incredible. So why aren't biomass heating systems taking over if they're so much cheaper and so climate friendly?
They're cheaper at the end when you save money, but on the overall, the cost of the boiler capital cost will be a little bit more than compared to any fossil fuel system. So where's the difference between having a biomass system is the difference on the capital cost, where anybody is looking at the capital costs and really doesn't look at the long term. They're only looking at the short term. But if you were to look at the long term, the biomass system is way, way, way better.
Mhm. Okay. So would you say then that it's economical to switch from a natural gas boiler to biomass boiler?
The proof is that the green a crane house, the one that I show at Sagville, 65% saving the first year.
Okay. Yeah. Okay. So I think we have time for one or two more questions. In your experience, how often do you need to refill the pellet storage at each boiler location?
It depends always on the condition of the season, the winter season, and it's also depending on the size of the wood pellet. I give you an example. The one at Grand Falls is the 50 ton silo. We have two trucks, a 33 ton and a 12 tons. So normally we deliver pellets about, see, consumption is about 450 tons a year. So once a month at the peak time during the winter time, and once every 3 months, and the rest remaining of the years,
Mm-hmm. Okay. And final question, how many tons of pellets will a typical commercial system use?
depending on the weather, depending on the size of the building that you have. It's a lot of different scenarios, different solutions. So it's hard for me to tell you exactly, but there again, if I give you another example, we have some installation that only takes about 12 tons. It depends on the size of the building. We have a maintenance building which is located not far from here, and it's 185 by 85, and it consumes about, I'll say, about 15 tons a year.
Okay. Yeah, that's good to know. So I think that's all the time that we have for questions, but thank you, Theo, for joining us today and giving that excellent presentation.